All right, let's take a look at our next example. For the next example, it says, suppose the number of new words you learn after T hours on uninterrupted study where T is between 0 and 10 inclusive is measured using the equation n of T equals to 20T minus T squared. How many words are learned between 2 and 3 hours? So in this particular case, you're figuring out the rate of change between 2 and 3 hours. In more specifically speaking, you're actually looking for the average rate of change here because I gave you an interval for time. So just like the previous example, what we're going to do first is we're going to figure out the number of words learned at 2 hours and then the number of words learned at 3 hours. And then we're going to figure out the slope of our secant line to figure out the average words learned per hour. So I'm going to do n of 2, which is going to be 20 times 2 minus 2 squared. And if I simplify that, that's going to give me 36. If I figure out the number of words learned after 3 hours, I'm going to do 20 times 3 minus 3 squared, and that's going to give me 51. So I've got 2 ordered pairs to work with now, 2 and 36. And then my second ordered pair is 3 and 51. This is x1, y1, x2, y2. And we're going to figure out the average rate of change here now. So that's going to be my y2 minus my y1 over x2 minus my x1. If I simplify that, I'm going to get 15 over 1, which just simplifies to 15. Now, in this particular case, what is the unit for our rate of change? So in this particular case, you have to know your independent variable and your dependent variable. So your dependent variable here would be words, and then your independent variable would be your time, which is in hours. So the average amount of words that you would be learning per hour is 15 words per hour in the time period of 2 and 3 hours. So therefore, the average rate of change is 15 words per hour. Alrighties, let's take a look at example 3b. So for example 3b, it says, what is the rate at which the student is learning after 2 hours into their study? What about 10 hours into their study? So in this particular case, again, I don't indicate are we looking at average rate of change or are we looking at instantaneous rate of change. But the dead giveaway for us here is that I'm looking for the rate of change at one point in time, and then I'm looking at the rate of change again at another point in time. So that means we're actually taking a look at the instantaneous rate of change. One at 2 hours and then the other one at 10 hours. So let's start off with 2 hours first. So dealing with IROC at t equals to 2. So remember, because we're dealing with instantaneous rate of change, we're essentially figuring out the slope of the tangent. So the first thing that we're going to do is we're going to figure out n at 2, which I knew from the previous example would be 36. And then we also have to create a second point, which is going to be created by n of 2 plus h. So that means I'm going to be plugging in 2 plus h anywhere I see t in my equation. So I'm going to do 20 times 2 plus h minus 2 plus h squared. If I simplify that, that's actually going to give me negative h squared plus 16h plus 36. So that's the second step. And then our third step is to figure out our instantaneous rate of change, which is essentially our slope of our tangent. So the instantaneous rate of change, remember, is the limit as h approaches 0 for n of 2 plus h minus n of 2 over h. And so let's plug in everything that we've got here. So n of 2 plus h is negative h squared plus 16h plus 36, and then minus 36 all over h. I recognize that 36 and negative 36 will cancel each other out. So then I'm left with the limit as h approaches 0 for negative h squared plus 16h over h. I realize that I can factor out the h. So I'm going to do the limit as h approaches 0. And then I'm going to have h, and then I'm going to get negative h plus 16 divided by h. Can cancel out the h's. And then I'm left with the limit as h approaches 0 for negative h plus 16. At this particular step, I notice that plugging in 0 for h isn't going to cause me any problems. So if I do that, I'm going to get negative 0 plus 16, which just simplifies to 16. So that means at t equals to 2 hours, the instantaneous rate of change for a student learning their words would be 16 words per hour. So that deals with at time 2 hours. Now the other part of this question is it also wants you to figure out the instantaneous rate of change at 10 hours instead. So we're going to take a look at the IROC at t equals to 10. So again, we're still looking for the slope of our tangent. So I'm going to start off by first evaluating n at 10. So if you plugged in 10 for t into your equation, you're going to get 100. And then after, remember our second step, we want to create our second point. So our second point is going to be created by 10 plus h. If I plug it into my equation, I'm going to get the following. And then if I simplify, I'm going to get negative h squared plus 100. So once I have this, I'm now going to figure out the slope of my tangent, which is my IROC. So to figure out IROC, we're going to do the limit as h approaches 0 for n of 10 plus h minus n of 10 all over h. So let's replace everything that I've got in there right now. I've got negative h squared plus 100 and then minus 100 all over h. Right away I notice, hey, I can cancel out the positive 100 and the negative 100. So I'm going to do exactly just that. And then I'm left with the limit as h approaches 0 for negative h squared over h. Again, in this particular case, it's actually a little bit easier. I notice that, hey, I can cancel out the square there and the h at the bottom. So I'm left with the following instead. As h approaches 0, I've got negative h. Now I'm going to plug in 0, and that just gives me 0. So in this particular case, the instantaneous rate of change for a student learning their words at 10 hours is 0 words per hour. And there we go. So in these two examples, we've shown you how to figure out your average rate of change versus your instantaneous rate of change given an equation. So in conclusion, a lot of the times when we do rate of change from a graph, it's not as accurate, but if you're only left with a graph, then you have to use a graph. But if you're given an equation, you can use algebra to help you figure out your rate of change. Now, the dead kind of giveaway from this lesson is the following. In order to figure out your average rate of change, you need to find the slope of your secant. Use the regular slope formula to help you with this one. I don't particularly like to say use the difference quotient. Use the regular slope formula from grade 9 to help you figure out the slope of the secant. To find the instantaneous rate of change, you're going to have to figure out the slope of the tangent. And that's where the formula that we learned from yesterday is going to be very helpful for us. That